Hi guys, this is Chevjin Academy. Welcome to this channel. In this video, I'm going to be showing you how you can correctly read slab reinforcement details and also interpret the reinforcements on bar bending schedule so you can give correct instructions for your iron benders on construction site. So we are going to be using this layout in this video, and as you can see, the layout consists of slab supported by beams and columns. So you can classify this kind of slab as a solid slab. So you can see the dimension of each of these slab. We have panel 7, which is about 5.3 by 3.9. These dimensions are in millimeters. The size of the beams are 230 by 450. Most of the columns are 230 by 450 columns. Then another additional information we have on this layout is the shear wall. So this is a shear wall that is going to house the elevator. See that the slab has a thickness of 150. So the detailing of this slab is going to go like this. So this is actually how the detail of the slab is going to look like. So the first thing you have to identify on any slab reinforcement detail is the reinforcement identification. So each of these reinforcement has what we call identification, or what we call name, or the nomenclature of the reinforcement. As you can see, the first reinforcement here has an identification which reads 12Y1201-200 BT inside brackets. So I'm going to be explaining what each of these actually means. The first thing here is 12. So this 12 is trying to denote the number of reinforcement. So the number of the reinforcement. So you can see that this line actually comes out from the slab detail. And on the line, you can see two arrows. These arrows indicate where the reinforcement started from. You see it started a little bit away from the beam, and then where the reinforcement ends. So the reinforcement ends here. So each of the reinforcement are what we call the call out. So this call out is this arrow that shows the position, the start and end of the reinforcement, and also extend outside so as to place the nomenclature of the reinforcement. Then you can also see this donut. This donut is trying to indicate that this call out is for this reinforcement. You can see that for this reinforcement, this vertical reinforcement, we have a donut that is trying to show that this line, this fourth nomenclature line, is for this reinforcement. So the same thing applies for all the reinforcement on the slab layout. So the first element, which is 12 in the nomenclature of reinforcement, signifies the number of reinforcement. As you can see from the slab detail, you can see that this donut, it shows that from here to here, this number has a number of 12. It has a number of 12. Then the Y after 12 signifies the type of reinforcement. We have two major types of reinforcement commonly used in construction. We have the mine steel and we have the high yield steel. So whenever the type of reinforcement is represented by Y or T, they usually signifies high yield steel. But when you use other alphabet, which can include M or any other, then it can indicate mine steel. Or you can even check the general note that follows the structural document to see the meaning of each of these. Then we have 12. 12 after the Y signifies the bar size. So that means this reinforcement that they do not identify, has a bar size of 12 millimeters. Then we have a dash line. After the dash line, we have O1. O1 signifies the bar mark. The meaning of this bar mark is, if you want to look up for this reinforcement in the bar bending schedule, you just go and look for bar mark 1 reinforcement. So once you see bar mark 1 reinforcement, that means you've been able to, that is the reinforcement. And from the bar bending schedule, you can see the shape of the reinforcement, and you can also see the dimension of each shape. So the bar bending schedule gives you the cutting length of each shape in a reinforcement. For example, this reinforcement with bar mark 1, you can see that the reinforcement forms a hook length. You can see we have a small length here, which is the return of the reinforcement into the slab section, and then you have the bottom part which extend up to this beam. So if you check the bar bending schedule for bar mark 1, you'll be able to see the dimension of this length, of this long length, the dimension of this short length, and you also see the dimension of this hook. I hope you understand. Then after the O1, we now have the dash. Then after the dash line, we have 200. This 200 signifies the spacing between this reinforcement. So let's say the spacing is not 200, it's something else. That will affect the number of reinforcement. So then we also have BT. BT signifies bottom top. So the BT, which is inside the bracket, is trying to show the position of the reinforcement. We have bottom. I will show you example of some bottom. You can see this one, this reinforcement by Mark 12 is bottom. We have bottom top. That is bottom is the reinforcement that is placed just after you've placed your cover for the reinforcement at the bottom of the slab. Then the reinforcement that is laid perpendicular to the bottom, but on top of it, just on top of it, is referred to as the bottom top. Then we also have another reinforcement that is called top. Example of this is bar mark 4. Bar mark 4 is a reinforcement with position of top. That is at the top of the reinforcement. This reinforcement is placed just, there is only cover between the tip of the slab and the reinforcement. So that reinforcement is top. Then the reinforcement placed perpendicular to this reinforcement below it at the top position of the slab reinforcement is referred to as top bottom. An example of that is bar mark 3. So most of the time, the main reinforcements in slab detail are usually the bottom, the bottom top, and the top. So those are the three positions for main reinforcement in slab. While the top bottom position is for distribution bar. So that means bar mark 2, for reinforcement with bar mark 2, you can now see that this reinforcement has a number of 4 because 4 starts from it. Then is an high yield steel, and then the size is 10 millimeters. The bar mark is 2. If you want to find this reinforcement on the bar schedule, you look for bar mark 2, and then the spacing is 250. You can see that the spacing is a little bit different from the spacing of 200, and the size is also different. The reason is because it is a distribution reinforcement. You know, I told you distribution reinforcement in slab are placed at top bottom. I hope you get. And the number is 4. But if you check the reinforcement itself, it's just a straight line, and then it has 2 arrows. We have one starting from here and ending here, and we also have another one starting from here and ending here. You can look at where my mouse is hovering about. So from here to here is 2 number, from here to here is 2 number. So 2 plus 2 will give you 4. So that's why the bar mark, the number is 4. And this is how each of these reinforcements are detailed. So let us now look at the bar bending schedule. The bar bending schedule actually takes different form depending on how you want your bar bending schedule to look like. But the most important element in the bar bending schedule is so that you're able to determine the quantities of reinforcement. So the first element here is the BM. The BM signifies the bar mark. So if I say that a reinforcement has a bar mark 1, so that means if I come to the detailing slab, so I'm referring to this reinforcement with the bar mark 1. So or the bar bending schedule, so that means this is the reinforcement, the bar mark is 1. If I want to look for a reinforcement with bar mark 10 on the drawing, all I have to do is, this is bar mark 10 reinforcement. If I want to know the size, the length of this straight bar, all I have to do is come to the bar bending schedule and look for bar mark 10. You can see that for bar mark 10, the size, the next column after the bar mark is the size of reinforcement. This actually gives the diameter of the reinforcement. So we can see that bar mark 10 has a diameter of 10 mm. Bar mark 1 has a diameter of 12 mm. Bar bending schedule is just a summary of the slab detailing. I hope you understand. So then we now have the quantities. The quantity is the number of reinforcement that you have on that slab. For bar mark 1, we have 12 number. Then we have the length. You can see this length signifies the total length. You can see that bar mark 1 has it has an hook shape. You have a straight line and then you have an hook. So the total length of all those lengths is this dimension 60, 65. So if the iron benders want to cut for bar mark 1, this is the length they will cut. They will cut 6 meters, 65 millimeters. I hope you understand. And then this is the shape. This shape, depending on how you arrange your bar bending schedule, like I mentioned, bar bending schedule can also take different form. You can see that for bar mark 1, it forms the hook just like the way you have it. The longer side has a length of 53565, while the return length here is 100. So and then the return to the reinforcement is 600. So that means on the slab detail from here to here is 5365, and then from the tip here to here is 600, and then this bent bar is 100 millimeter spacing. So the dimension of this is in millimeters anyway. So this total is calculated by multiplying the quantities by the length. So if you multiply 12 by the length and this length is in millimeters, then you get the total in meters. You divide by 1000 to get the total in meters. So this is how you can read the bar bending schedule together with the slab detailing. Then another important things that you can also get from the bar bending schedule, aside from the shape of the bar as well as the cutting length, is the total number of reinforcement or total tonnage of reinforcement. So and how do you calculate that? You calculate that by adding up the total length. This total length, you add everything together from bar mark 1 to bar mark 18. You can see that the bar bending schedule, we have 18 type of reinforcement. So if you come to the slab detailing, you see that you have from this is bar mark 1. This is actually arranged in order. This is up to bar mark 11. Then we have 12, 13 up to 18. And bar mark 18 has a diameter of 12 mm with a number of 6 and a spacing of 200. I hope you see this. So if you come to the bar bending schedule, you see that is actually what we have. Bar mark of 18, bar size of 12, number of 6, and then this is the shape. If you come to bar mark 18, let's see bar mark 18. So this is bar mark 18. You can see the shape. So it forms that shape. So that is why you have it on the bar bending schedule. So how do you now calculate the total weight of reinforcement? So from this slab, we have two type of slabs. So this is the summary of the schedule. We have Y10 and we have Y12. So you add up the total length of Y10. This is the total length of Y10 according to this example. Then you add up the total length of Y12. This is the total length of Y12 according to this example. Then we have what we call the unit weights. Each size of reinforcement has its own unit weights. I hope you get. So if you are using the SI unit in millimeters, kilogram and meters, so the unit weight is given by the formula d square over 126. D refers to the diameter of the bar. So if a reinforcement has a bar size of 10 mm, so that means using that formula, the unit weight of that reinforcement is d square, that is 10 times 10 divided by 162. So that is 0.617, and that is what you have here. You can do the same thing to calculate for Y12 as well. Then to now get the total weight is just the multiplication of the unit weight by the total length, and it has to be in, the unit weight is in kilogram per meter, the length is in meters. So when you multiply it, you have 90.8, and here you have for the Y12 you have 905.69. Then D is going to give us 996.49. But the reason why we have this times 2 times 2 times 2 in this table is because this is the second floor slab detail. The second floor and the first floor for this project is the same size, and then the slab detailing is the same. So but we don't want to be repeating them, so that's why we put this times 2 times 2, so that when the QS is working on this project, he will understand that all these bar reinforcements are actually repeated 2 times in the building. I hope you understand. So that is why we have this times 2 times 2 times 2. So this is how you can read your slab detailing and also correlate it with the bar bending schedule. If you like what I've shown you, kindly hit the subscribe button. This will allow others to see this video and also learn from it. And if you are interested in learning how to actually detail slab, you can check out this video on Udemy. It's just a video on slab detailing for reinforced concrete structure using AutoCAD. In this course, you are going to learn from scratch how you can detail different kind of structural reinforced concrete elements, from slab, beam, column, shear wall, staircase, foundation, and others. Then you also learn how to plot. But in case you are interested in learning design, you can check out my website, chefjinacademy.com. On that website, you see a lot of courses on structural design. Thank you. We'll see you in the next one.